So in this video, we're going to take a look at the Cox-Ross-Rubinstein model. And we've taken VBA code from curryback.net. We copied the function here. And we copy and we'll paste into Excel. And the idea will be that we will observe how to implement the binomial model. So we have to go into the Visual Basic Editor, insert a module, paste the code in with the code is there. We go back out into our worksheet. In fact, perhaps we might just copy the name of the function and the order of the variables. So we copy and we may paste that here just so that we can see, and maybe increase the size of this a little bit. Now, a couple of things. We will look at also at the convergence behavior of this algorithm. So we've SK, the stock price, the exercise, the risk-free rate, the level of volatility, sigma, the dividend yield continuously compounded, the maturity of the option, and the number of steps. And so far, we've been working with values of 100 for the exercise, the risk-free rate of 5%, the sigma of 20%, the dividend yield of 0. Time period is 12 months or 1 year, and we can go with 100 steps in the binomial tree. Okay, to invoke our function, just European, and it's already been recognized. So the user-defined function has been recognized, and then we can fx, and we can bring this a little bit closer so the arguments can just automatically go in. The exercise is 100, the risk-free rate is 5%, the sigma is equal to 20%, the dividend yield 0, and the time period is, or maturity of the option is 12 months or 1 year, and the number of steps here is equal to 100. Okay, so the value we get for a 100-step option is 1043. The true value we know from Black-Scholes would be 1045. Let's get some of that code. Okay, so where might we find that? We would find that in our Vinegar Hill lab, right? So let's go back to Black-Scholes, and we come down here to, again, VBA code obtained from curryback.net. The first segment here just relates to a call option. We'll copy, and then we'll go back into our spreadsheet and go to the Developer tab, Visual Basic Editor, and we can insert a new module, insert module, and paste. And now we have Black-Scholes call. The order of the variables is the same as before. We can do a check and dot. Let's just copy the name of the function, come back out. We'll put the Black-Scholes above, so we'll just paste, and you can see here SKR sigma QT is the same order as here. So if we pulled these variables across and we pulled this across and change the name of the function to Black-Scholes call. Right, so once I start writing Black-Scholes, I'm being prompted, and that's the name of the user-defined function. But we don't require the last variable, right? So we can leave that out, and we should get a result of 1045 exactly. Okay, and we don't have a step size in Black-Scholes. This is true. And this is an approximation. And we normally, when we look at binomial code, we increase the step size to see, are we converging closer to the true value obtained from the closed form solution. So we could start with 10, we could do 50, we could take that up to 100, we could take that up to 1,000, 1045, we could take it to 2,000, and you can see each instance we're getting a little bit closer. 2,000 didn't work. Let's go 1,000 is fine. 1,500. Okay, so what we find actually happening here is there is an actual limit in terms of how far we can raise the number of steps here with the type of code that we have, and the binomial model is cropping out. We could try 1,200. It might work. It doesn't. We could try 1,000. We could try 1,100. It doesn't work. Once we go above 1,000, it seems to crash out. Okay, so we're quite close, but obviously there are limitations then with this European call function, and that suggests that we should try to implement other types of code to optimize. Also, this is just for a European option, and the big strength of using binomial is that we can estimate the value of the American option. If we look at the code here, right, that we have for the binomial, you can see there's no reference to American options. So this is purely to estimate a European option, and tends to crash once we go over 1,000 step mark or a little bit higher, but not above 1,100 because we tested that. Okay, so we'll stop recording